Hey guys, this is going to be our last section in chapter 9. Solving systems of equations means we are solving for an x and a y ordered pair. So let's just review. Let's review a couple of things that we've already talked about. We have 3 scenarios happening when we're solving for systems of equations. Our first scenario is that my 2 lines, one in red, one in blue, intersect and we create an XY point. This is what we typically look for, but not all the time does it happen. My next scenario, my 2 lines, one in red, one in blue, are parallel. This creates no solution. And my last scenario is if I have a line and then I have the exact same line in blue, this creates an all solution. Sometimes you'll see it as infinite number of solutions. So just be prepared that all and no solutions might not be exactly those words. So today we're going to use what we call the addition and subtraction method. The addition and subtraction method is also called the elimination method. So if you see this on Delta Math or Khan Academy, you will actually see the word elimination method. Let's talk about what elimination means. Elimination means we're going to get rid of it. We're going to eliminate something. Our essential question is, can you use the addition or subtraction or the elimination method to solve systems of linear equations? So let's take a look. Example 1 is set up really nicely for us. Notice that example 1, if I was to add down, notice that a positive y and a negative y will just cancel out. So we end up with 2x, and that's equal to 18. And I know you guys have already solved where x is equal to 9. Great, we have our x. We just need our y. So let's go back to the original. X is 9. 9 plus what gives me 14? Well, when I subtract 9 to each side, notice that y is 5. So my ordered pair is 9 and 5. Now, this is going to get a little bit more difficult as we move on. This example and example 3 are pretty good, where I might have to teach you, I have to teach you one more lesson in this case. Example 2, notice I have a positive 3r and another positive 3r. So I know already you're saying to yourself, wait, those aren't positive and negative. So on the bottom, I would just multiply all of this through by a -1. And when I multiply that all the way through by a -1 and add down, notice my 3r's cancel out. Well, 2s minus s is equal to s, and 2 minus 7 is equal to -5. We've got it. Let's move on. Let's go ahead and solve the next one. I'm going to solve it in blue. If I plug it into here, 3 times what plus 2 times -5 is equal to 2. Well, I know that 2 times -5 is -10. So 3r minus 10 equals 2. When I add 10 to each side, 3r is equal to 12. And when I divide each by 3, r is equal to 4. So I can write my ordered pair in that order, 4, -5. Notice it's usually in alphabetical order. R comes before S in the alphabet. All right, let's try one more in this section. Example 3. Example 3 is very similar to example 1, where I know if I add down, what's going to happen with my -y and my positive y? Very good. Those are going to cancel out. 5x and 3x is 8x. 12 and 4 is 16. I know you guys have already solved for that. What is x equal to? x is equal to 2. Very good. Let's plug it in. I always plug it into an original. So I know 5 times 2 minus what gives me 12? Well, 10 minus y is 12. When I subtract 10 to each side, negative y equals 2. So y has to equal negative 2. So that ordered pair is 2 and negative 2 for your x and y. Great job.